Hi, this is Kevin, and we're group number 4, and we'll be working in chapter number 10, Enable Fast and Reliable Automated Testing. In this chapter, we'll be studying the benefits, the advantages, and the main objective of implementing automated tests and integrating practices and environments. So if we move to the next slide, we have the first principle, which is perform continuous build test and integration practices and environments. So basically, the more work we do and we cover will require more time to test the code. Right? So in most cases, this is a totally unscalable business model for any technology organization. And we're providing an example of how integration can flow in the same process through the graphic, through the image we have in this slide. And then if we move to the next one, to the slide number 3, we have the same principle, but explaining a little bit more about this. So by doing this, by integrating, testing, we find any build, test, or integration errors as soon as a change is introduced, enabling us to fix them immediately. Hence, will require less time. It doesn't mean it will have less work, but it will be more productive and more efficient. So done correctly, this allows us to always be assured that we are in a deployable and shippable state. And then we have this little example of how the continuous integration works and with all these stages of the development process as well. Then moving to the next slide, and the slide number 4, we have the next principle, which is build a fast, reliable, and automated validation and test suite. So the main purpose of this is having constant feedback to improve the process. Since slow and periodic feedback kills, especially for larger development teams, and it's even worse when you have tens, hundreds, or even thousands of other developers checking their changes into version control each day. So we have divided the process, or in general, automated tests fall into one of the following categories, from fastest to the slowest. And the first one is the unit tests. The second one is the acceptance test, and the third one is the integration test. Um, the unit test, basically, they typically test a single method, class, or function in isolation, providing assurance to the developer that their code operates as designed. And the second one is the acceptance test, and these typically test the application as a whole to provide assurance that a higher level of functionality operates as designed. And the third one, which is the integration test, they are where we ensure that our application correctly interacts with other production applications and services, as opposed to calling stopped out interfaces.
Hi, this is Jennifer Harmon. We should design our tests to try and catch errors as early as possible. When it comes to finding and fixing errors, the sooner we catch them, the easier they are to fix. This also saves us time in testing code that is ultimately going to fail. As mentioned before, the fastest tests to run are unit tests, and so it is best to find errors here where they are easier and quicker to fix than acceptance or integration test errors. When we find errors during acceptance or integration tests, we should create a unit test to find the error. This will take less time and make it easier to fix the error. Our ideal testing pyramid will have most of our errors found during unit tests, with fewer errors found during acceptance testing and the least found during integration testing. On our next slide, we want to make sure our tests run as quickly as possible. This goal is best achieved by having a test suite that finds most of the errors during unit tests, since they are the quickest, but it also helps to run tests in parallel when possible. This means we run tests simultaneously instead of sequentially. This can dramatically decrease the test running times. We can run different categories of tests at the same time across many different servers. The amount of time we save is directly related to the number of tests we run at the same time. The increased speed for testing helps with our goal to optimize continuous integration and delivery. It allows us to get our code tested and fixed as quickly as possible.
Hello everyone, my name is Heston Moyers. I'll be going over the last couple slides in today's presentation. The first slide that I'll be going over is the writing automated tests before writing the code. Test-driven development. By doing this, we'll be able to solve a lot of the issues with the code before we actually send it out to the customers. Some of the things that we should do to prepare for that would be to automate as many of our manual tests as possible, so that way we can not be burdened by having to do it manually. Locate as many code errors as possible. Make sure we test the performance of our application as well as check for errors. And validate all aspects of the application, not just the code. The next slide is just the conclusion of what we've learned in this chapter. First, we learned that we need to create automated test, that we need to create a green build that is in a deployable state, that we need to create a deployment pipeline that consists of our test suite, and do everything we can to keep a green build state. This creates a stable environment that we can deploy tests and fixes to the issues in the code while delivering to the customer at the same time. Thank you for listening to the presentation, and have a great day.